Hello everyone. So now that the meeting is now being recorded, welcome again everyone to another lecture about principles of steel design. So for our lesson for today, I would just be discussing some additional parameters that you should take into consideration when you are to design your flexural members. So I'm pretty sure you've already watched the first pre-recorded lecture about the design of flexure members. So in that meeting, we have solved for the nominal bending moment stress. I mean the nominal bending strength of your flexural members. So when you are to design your flexural members, of course, the first thing that you should take into consideration is the bending moment itself. So once again, ito yung pinag-usapan natin doon sa una nating pre-recorded lecture. So, bending moments. Confirmation everyone, nakikita nyo ba yung sinusulat ko?
Yes, sir.
Okay.
Yes, sir.
So, ito, bending moment na to. So, in this, we have already discussed this once again. And dito, we would be comparing your MA, your allowable moment, and your ultimate moment with your factored moment. So, ito ASD, ito LRFD. And if you can remember during that pre-recorded lecture that in order for you to solve this, you must check if your flexural member would be experiencing lateral torsional buckling, yung may zone 1, 2, 3. So, yan yung una nating pre-recorded lecture. And, ayan, since yan yung number 1, of course, meron tayong number 2. And suppose that this is to be your member right here. So, ito kunwari yung flexural member natin. Itong bending moment natin na to is caused by your, of course, bending moments. Yan pala. Yung bending stress natin is caused by your bending moments. And these bending moments right here can be caused by couples or loads that are traverse to your section. So, by traverse loads, ito yung mga traverse loads natin. So, pwede tayong magkaroon ng point load. Pwede rin tayong magkaroon ng uniformly distributed load. Like this. So, hindi lang maganda yung pagka-drawing ko, but you get my point. So, pwede din yung ganyan. And of course, if your member would be subjected with lateral loads, an internal stress that can be caused by it is what you could be calling shear stress. So, itong stress na to, itong red na to, is what you would be calling shear stress. So, teka, tanggalin lang natin para may mapagsulatan lang tayo. Okay, so kung shear stress yan, so self-explanatory, the second thing that we should take into consideration is shear. Of course, we don't want our members to fail in shear. So shear, this would be VA and VU respectively. So allowable stress and ultimate stress. Once again, ASD, LRFD. So once you have solved for your VA or VU already, you would be comparing them with your shear diagram, yung maximum shear nyo sa inyong flexural members. So that is number 2. And number 3, since our steel members are very ductile members, it is still susceptible to deflection. Teka, nalulutang ako. Okay, so deflection. So, ayan. Of course, we don't want our member to deflect by that much. So, hindi natin maiwasan na mag-deflect siya. Pero dapat, meron tayong limit ng kanyang deflection, which I would be showing to you later. And last one. So, for example, that we have concentrated loads, we must check if it would be adequate in local failure. So, local failure. So, dapat hindi siya mag-fail locally. So, it would be as simple as that. So, once again, we have already solved for this. We have already discussed about this number 1 right here in the previous pre-recorded lecture. So, I think dated 2 weeks ago. So, nagawa na natin to. And as for these 3, I would be discussing it to you this meeting. Okay, so, second things second. Ito number 2 natin. So, we would be solving for the shear capacity of our member. So, shear. So, this is pretty much straightforward, guys. So, direct substitution lang. And for you to get the nominal shear strength of your member, that is to be 60% of Fy web times A area of the web times CV. So, ayan siya, no? Confirmation. Check ko lang kung tama ba yung pinagsusulat ko para di ako mapahiyanan di oras. Okay, asan ba yon? Okay, hindi ko makita pero yan yon. Basta sure ako dyan, di ko ma-confirm pero sure ako dito sa equation na to. Okay, so this is to be your equation where your FYW would be the yield stress of your web, your AW would be the area of the web, and your CV would be these factors right here. So, pwede yung 1.0 siya, pwede yung 1.0, 1.0, then pwede din itong equations na to. So, it would depend upon what case your structural member would have. So, if it would be having webs of I-shaped members, so when your H2 thickness of the web ratio is is less than 2.24 square root of E over Fy, you would be using this. And as for the value of your phi and your omega, so eto din siya, but wala akong may sulat. Okay, anyway, eto siya, or eto. So, ayan, pretty straightforward. All of these factors right here can be seen in your AISC shapes database. So, meron tayong H, meron tayong TW, meron tayong CV, meron tayong, ano pa ba? E, meron tayong FY, so lahat yan given yung mga yan. Okay, but ano pa ba yung mga kailangan ko pa sabihin dito? Oh, by the way guys, since you are to consider AW here, so for example that this is to be your member right here, confirmation guys, nakikita nyo ba yung figure sa harap nyo? Malamang. Pero, ano yung nakikita nyo pala guys? Ano yung nakikita nyo? Yung pala yung tanong ko dapat. Sorry.
Cross-section, sir, ng...
Okay, so ayan, very good. Since it is said here that you are to use area of the web, so kapag una natin mabasa yan, ang unang i-assume natin is ang web natin is eto lang, di ba? So yan lang dapat yung web natin. But in AISC, this area of the web right here should cover these areas right here. Teka, nasa eraser ko. Okay. So it should cover from top to bottom. So, ito daw yung magre-resist sa ating shear. So, parang inalis lang natin yung webs ng flange. So, if this is to be the area of the web that would be resisting the shear, so our area of the web, AW, is equal to depth times thickness of the web. So, once again, hindi lang etong part na to. It should be this hole right here. So, once again, the overall depth times the thickness of the web. So, ayan yung AW natin. And for us to get the value for CV, ito nga yung titignan nating mga factors kung saan siya mag-fall. Okay, so it is said here, ang i-compare nyo is yung slenderness ratio niya, H over TW. Ba't ayaw masulatan? Okay, H over TW. This H over TW right here is actually on your AISC shapes database already. Pero for example, hindi pa. Isa-solve nyo pa lang. Itong H over TW na to, of course, itong TW nyo is the thickness of the web. And this H right here is this H right here. I think I have already discussed about this in the pre-recorded lecture. So, dapat mag-start siya dito, then mag-end siya dito bago yung weld. Kasi itong part na to guys, welding yan. Ayan. So, dapat ito lang yung H natin. And for us to solve for that, by the way guys, this length right here, so from the top up to that point and from the bottom up to that point, that is variable K. So, K yan. So, for you to get the value of H, so from that, your value of H would be depth minus 2 times K. So, etong red part lang na to. But di ko pinili yung red na color para sa ink natin. So that is to be for the value of your H. Once again, it would just be this part right here, yung red. Okay, so ayan, no, ano pa ba yung kailangan nyo malaman dito? So once again guys, if you would be having your I-shaped member with the height to thickness of the web ratio that is less than this value right here, you would be using CV is equal to 1. So etong CV na to 1.0 siya. But take note guys, your phi and your omega would be 1.0 and 1.5 respectively. So this is for LRFD and this is for ASD. Tapos, sabi dito, if you would be having your webs all doubly symmetric shapes, singly symmetric, and channels except round, hollow, steel section, gagamit kayo ng phi and omega na 0.9 and 1.67, and you would be checking your cases here kung anong CV gagamitin nyo. But if you can see here in this equations right here on the bottom, meron tayo yung tinatawag doon na KV. So, kung makikita nyo man dyan, may KV dyan, and the value for KV is equal to 5 when your H to TW ratio is less than 260. That is if you would be having webs that doesn't have traverse stiffeners. And kapag meron naman, you would be solving for KV. KV is equal to 5 plus 5 over A over H squared. Pero for our case right now, ito muna yung iti-take into consideration nyo. So, once you have solved for this already, so yung Vn nyo, you would be applying your reduction factor or your safety factors para makuha nyo yung VA and your VU. And you would be comparing it with your maximum shear that you can see in your shear moment diagram. So, pwedeng negative shear, pwedeng positive shear. Basta kung ano yung shear na makita nyo sa shear diagram nyo, compare nyo dito. And dapat, etong value natin na to is greater than your actual shear. So, ito yung strength natin, then yung actual shear nyo dapat mas mababa dito. Kasi pag mas mataas yung actual shear nyo, edi hindi na safe yung section nyo. Okay, so for our next one, so deflection limit. So, ito yung sinasabi ko kanina na dapat yung section nyo, kung magde-deflect man siya, dapat it should be less than these limiting factors right here. So, for example, that your steel section is for floor members. So, for example, that you are to consider your section to be to be a girder or to be a beam, you must check these loading conditions right here. The deflection limits from IBC 2009 using these loading conditions right here. And kapag deflection naman yung pag-uusapan natin, you wouldn't be using factored loads here. Service loads lang. So, by service loads, ibig sabihin yan, ito, hindi siya factored. As simple as that. So, L or DL or whatsoever. So, for example, that you are only to consider live load in your analysis, your beam should not deflect greater than L over 360. So, for example, that ano nangyari sa calculator ko? Teka lang. So, for example, that, looking at the calculator to your left, so, kunwari, 6 meters yung ating beam. Then, if you are just to consider live load here, so your 6 meter beam should not deflect by L over 360. So, L over 360 is equal to 16.666 millimeters. So, dapat di siya lumagpas ng 16.66. But for example, that this 6 meter beam right here is to be subjected with, if you are to consider dead load and live load together, so D plus L yan, and for that, you would be using this limiting factor right here, which is L over 240. So, kapag dinivide ko to ng 240, so that would be 25 mm. So, dapat ang maximum deflection mo for your beam is to be 25 mm or roughly 1 inch. So, self-explanatory and direct sub lang yan. So, I wouldn't be giving you some examples. So, once again, direct sub. So, that is it for deflection limits. Next up tayo. Oh, by the way, yung sa deflection nyo, you can solve for it via any method you want, kung gusto nyo by integration and whatsoever, or kung gusto nyo by formula na lang, for example, that you would be having a certain member that would be subjected with a uniformly distributed load, ito lang yung gagamitin nyo. And I'm pretty sure you're already familiar with this already. Double already yun. Okay, so your maximum deflection, if you would be having your structure to be subjected with uniform distributed load, so that is to be 5 omega L raised to 4 divided by 384 EI. So, kayo na bahala kung ano yung gagamitin yung formula and kung ano mang loading condition yung nararapat. Okay, so that is it. So, next up, local failure naman tayo. So, pretty much lahat na pag-uusapan natin dito is direct substitution. Etong local failure natin is what we would be calling the failure of the webs and the flanges if you are to subject your members with concentrated loads. So, for example, that you would be having your member right here. Oops, tumabing yung member ko. So, ito yung member natin sa side view. Then, if you would be having some concentrated load. So, for example, meron kang sobrang laking load na point load. So, you would be checking if your webs or your flange would not fail. So, the first thing here that we should take into consideration is the local flange bending. So, ano ba ibig sabihin yan? So, for example, that you would be having your flange here. I mean, your wide flange o kaya I-beam. So, depende na. So, ayan, no? So, kunwari yan yung ating wide flange or I-beam. Yung local flange bending is that yung flange mo, which is, well, kung top or bottom, magbe-bend lang siya, literally. So, it would be, ang pangit. Okay, so it would be like this. So, magbe-bend lang siya ng ganyan. So, ayan, paano mo ba malalaman kung magbe-bend siya ng ganyan sa local flange bending? So, you would be comparing this. So, Rn is equal to 6.25 times thickness of the flange squared times the yield stress of your flange. So, direct substitution. Etong TF natin is this thickness of the flange right here. So, TF. And your yield stress of the flange, of course, is the yield stress. So, direct substitution, isolve nyo lang yan. And your phi here, phi is equal to 0.9. And your omega is to be 1.67. So, kapag ma-isolve nyo na tong Rn na to, apply nyo na itong mga factors na to and compare it with your point load. So, if, for example, that this is to be your point load, your Ru, saan ba pwede magsulat? So, your Ru should be greater than or equal to your Pu. Or your and your Ra should be greater than or equal to your Pa. So, ayan lang yon. So, another thing that we should take into consideration is the local web yielding. So, ano ba tong local web yielding na to? So, for example, meron na naman tayo dito. Kopyahin ko na lang para hindi na ako mag-drawing ulit. Okay, so for example, meron tayong member na to. Delete ko lang. Yung local web yielding na yan is literally mag-yield lang yung inyong web. So, ang mangyayari dyan, parang kunwari itong part na to ng web nyo, lolobo siya dito. Ang tawag dyan, magpupush out. So, parang lolobo siya dyan. Then, ayun, nag-yield na siya. So, for you to check the limit of your structural member, you would be looking at this figure right here. Kapag magkaroon ka kasi ng point load dito, madidistribute siya up until this point right here. Ito yung critical area ng ating web. So, itong area na ito. So, once again, simple lang ito. Your Rn. Sabi yung pen ko. Okay, your Rn is equal to this area right here. I mean the cross-sectional area of this part right here. Oh, by the way guys, itong nakikita nyo dito is the side view of your structural member. So if this is in your web, the area of that part right there is 2.5K plus LB plus 2.5K times the thickness of the web. So 2.5K plus 2.5K, that is to be 5K plus LB times thickness of the web. So ito yung area natin. And you would just be multiplying this by the yield stress, which is Fy. Yung yield stress nyo ng inyong web. So that is the formula if you would be considering this one right here kapag nasa midspan siya or any location that is not on the edge. Kasi kapag nasa edge naman, which is this, kapag ito naman yung i-consider natin sa edge na to, ang Rn yan is to be equal to, so if you can see this length right here, this is to be LB plus 2.5K. So ito, LB plus 2.5K. So 2.5K plus LB times thickness of the web times yield stress of the web. So yan yung i-consider nyo. And your phi right here, phi is equal to 1.0 and your omega is to be equal to 1.50. So LRFT ASD. And you would once again be comparing this Rn right here to the point load that that is subjected to your structural member. So ito P. So RU compare nyo sa PU, RA compare nyo sa PA. So ano ba yung bago dito? Etong K na to, alam nyo na to, no? Parehas din lang siya sa pinagsasabi natin kanina dito, which is this. That is the value for K. And as for this LB right here, etong LB na to, is the length that your point load is covering. So for example, sobrang bigat na tao yan. Example lang to pero hindi ito yung case. Example, sobrang bigat na tao yan. Then yung paa niya, let's say 1 foot. So 12 inches. Yung LB nyo is 12 inches. Basta kung ano man yung length na kino-cover ng inyong point load. So for example, meron kayong planted column and yung planted column nyo is, drawing lang tayo. Yung planted column nyo, ito pala yung beam nyo. Then you have your planted column here. By planted column, ibig sabihin yun yung column na nakapatong lang sa beam mo. And for example, that is to be your planted column. And the dimension of this column right here is 250 by 250. So, ang LB nyo is 250 mm. So, ayan. Okay, any questions so far?
None, sir.
Okay, how about for the others? Naintindihan ba? Direct sub lang naman?
Sir.
Okay. Miss Maneha, kuha.
Yes, sir.
Okay, how about for Miss Gonzalez, kuha?
Yes, sir.
Okay, so direct sub lang naman to once again. Okay, so speaking of direct sub, dito naman tayo sa web crippling. And sa web crippling, ganito kasi yung magiging behavior niya. So for example, that this is to be our section. So, kunyari, ito yung section natin. Literal, mag-cripple siya about a certain point. Medyo OA lang, pero ganyan yung itsura niya. Basta yung isang part natin ng ating web is, well, literal, mag-cripple. And ito, para malaman natin kung ano yung ating Rn or the point load that it can carry without crippling, ito yung mga formulas natin. So once again, direct sub. Pero parang ang dami ng formulas. So this formula right here can be used. So itong una, this formula right here can be used if the location of your point load is right here. Drawing ko na lang. Hindi ko lang pa paano ko explain eh. So for example, that this is to be your member once again. And of course, your member would be having a depth, corresponding depth. So, ito yung depth natin ng ating beam. And d divided by 2, if you would be dividing your depth by 2 and you would be projecting it here. So, for example na, kahirap naman mag-drawing dito. So, ito yung ating d over 2, for example. Then, ito yung ating d over 2. Hirap mag-drawing. Okay. So, papala natin. D over 2 yan. And ito yung D over 2. Depth over 2. If your point load would be from here, would be here, or let's say here, basta kahit saan in this region right here. So, pag yung point load mo is in this region right here, kahit saan dyan, you would be using this equation right here. But if your point load would be located here in these parts right here, you would be using this equation right here. So, it may either be this or this. So, kapag nandyan yung location ng inyong point load dito sa areas na to, you would be checking the ratio of your LB divided by D. Itong LB natin, hindi yan unbraced length. Yung LB na yan is this one once again, kung gaano kalaki yung inyong point load. Kung kunwari is column yan, kung gaano kalaki yung column mo. Yan yung LB mo. And as for your D, that is to be the depth of your flexural member. So, ayan. Ano ba yung bagong term dito? So, meron tayong thickness of the web. LB, nasabi ko na yan. Itong D, alam nyo na din yan. Thickness of the web divided by thickness of the flange. Alam nyo yan. So, basically, alam nyo naman lahat ng mga parameters na nandito. I-check nyo lang ulit yan sa inyong AISC Shapes Database or given yan. And kapag board exam pala, guys, binibigay lahat ng yan. Minsan pa nga, itong formula mismo yung binibigay nila. So, ayun. So, that is it for web crippling. Then, we also have the compression buckling of web. So, ito, self-explanatory, magbabuckle lang yung compression side ng web. Okay, so, ito na yung formula mo. Kailan ko pa bang explain? Wala naman nata akong kailan explain. Ito na, emphasize ko na lang. Itong H na to is this one right here once again. So, itong part lang na ito. Napakaayos naman ang drawing ko. Okay, ayan. So, ito yung H natin. Yung depth minus 2K. Okay, so meron pa ba akong kailangang sabihin? So, ito, may note siya dito that if the concentrated load to be resisted are applied at a distance from the member end is less than D over 2, then the value of your Rn shall be reduced by 50%. So, meaning, if your load is once again in this region right here, so ito, kapag malapit siya sa inyong supports or sa inyong edges, by D over 2. So, once again, kung nandito siya sa area na to, kung ano man yung masolve mong Rn is marereduce mo by 50%. So, self-explanatory. Ayan lang yan. Okay, so naubusan ako ng slide. Anyways, are there any questions? Naintindihan ba, guys? Puro ano na lang to? Direct sub? Kuha ba? O Mr. Domingo, kuha ba? Or may tatanong ka?
Kuha, sir.
Okay, Miss... Sino pa ba? Miss Pasol, kuha?
Opo.
Okay, direct sub lang yan. Once again, Miss Mendoza, kuha?
Yes, sir.
Mr. De Los Santos, kuha?
Yes, sir.
Okay. So, teka, balik lang natin. No? Recap. So, kapag magdi-design kayo ng flexural members nyo, ito yung mga take into consideration nyo. So, yung bending moment. So, nagawa na natin to sa isang pre-recorded lecture, yung meron tayong lateral torsional buckling, meron tayong zones, meron tayong plastic moment and whatnot. Then after that, kung adequate na siya, i-check nyo din siya for shear. Ito pala guys, note lang, no? Sa totoo lang, halos hindi nag-govern etong shear natin. In most cases, magkakaroon ka lang ng shear failure kapag lumagpas ka na ng bending moment. So, ayan yon. I mean, ng flexural failure. Okay, so the third one, i-check nyo yung deflection nyo na dapat hindi siya masyadong malaki with the limiting factor that I have shown to you a while back. So, ito, dapat hindi siya lumagpas dito sa mga deflections na yan. And as for the last, yung local failure, so you would be checking this and if you would be having point loads, concentrated loads. Kapag meron kayong ganito, dun nyo i-check ang local flange bending, ang local web yielding, ang web crippling, and ang compression buckling of the web. So, ayan lang yan. Habang nag-iisip kayo ng tanong nyo, may i-explain lang akong isa about CB. Teka lang ha. Saan ba yun? Okay, so ito yung ating CB. So kung naalala nyo sa ating formula sa unang pre-recorded lecture, meron tayong CB dito kapag pumunta tayo ng zone 2. So kung medyo parang hindi familiar sa inyo tong equations na to, dapat nyo nang panoorin yung ating unang pre-recorded lecture about flexural members. So kung makita nyo dito, may CB dito and meron din yung CB dito. And dun kasi sa ating pre-recorded lecture na yon, yung CB natin was assumed as 1.0. But your CB, sa totoo lang, your CB can be solved by this equation right here. So that is to be 12.5 maximum moment divided by 2.5 M max, so maximum moment 3 MA plus 4 MB plus 3 MC. So, ayan, bitin lang. Teka, babaan ko lang ating line. Then, you would be multiplying this by RM. And in most cases, RM is equal to 1.0. And this formula right here is from page, anong page ba ito? Teka, hanapin ko lang yung aking, para lang alam nyo, 5-62. So, page 5-62 ng inyong NSCP. So, paano ba isolve tong CB na to? So, you would be getting the moment diagram of your member right here. So, kunwari, ito yung member nyo. Ito yung pala yung binigay ko notes kahapon. So, for example, that this is to be your structural system. Then, ito yung shear diagram natin. Then, ito naman yung moment diagram natin. And then, yung moment diagram natin would be like this. So, approximately, ganyan siya. Okay, so from that, kukunin mo ngayon yung inyong maximum moment, which is, supposedly, dapat dito yan. Pangit lang ng pagka-drawing ko. Okay, and etong X pala na to, by the way, for example, is your lateral bracings. So, etong pagkuha natin ng CB, I should say, etong M max natin, once again, is yung maximum moment. And after that, after getting that, etong unbraced length na to, i-divide nyo into 4 equal parts, 4 equal regions para magkaroon kayo ng 3 na lines. So, for example, yan. Kunwari, magaling ako mag-drawing, kunwari, ano yan. Talaga na-divide siya into 4. So, for example, that this is to be LB. So, etong mga to, LB over 4. LB over 4, LB over 4, and LB over 4. Then, you would be getting these points right here. And these points right here is your MA, MB, and MC. So, kanya-kanyang racket kung paano nyo kukunin itong mga values na to. Pwede kayong gumamit ng moment equations. And I think yun naman pinakamagandang way. Kunin nyo yung moment equation ng inyong figure. Then, ayun, kunin nyo lang itong MA, MB, and MC. So, after that, direct sub, M max, MA, MB, and MC. And kung ano man yung sagot nyo dyan, dapat hindi siya lalagpas ng 3. So, maximum natin dyan is 3. So, wala na akong pagsusulatan, no? I-check nyo na lang itong NSCP nyo to. So, 5-62. So, check nyo yan sa pagkuha nyo ng CB. Okay, so, naintindihan ba guys? Parang hirap, no, itong part na to. Pero, wala tayong no choice. Wala na kayong no choice. Kailangan gawin yan if magdi-design talaga kayo soon after.